It was, in fact, the supernova of a star originally about 10 times the mass of our Sun. The blast occurred about 6,500 light-years away from Earth. Had it been nearby, 50 light-years or less, the radiation would have destroyed every living thing on our planet. This false color picture of the Crab Nebula shows shreds of gas expanding from the supernova site. The colorful network of filaments came from the star's outer layers. Though they appear near the central star, the greenish filaments are closer to us and approaching at some 300 miles per second. The orange and pink filaments are material behind the star rushing away from us. The expanding shock wave from a 15,000-year-old supernova called the Cygnus Loop lies 2,500 light-years away in the constellation Cygnus. The loop is colliding with a cloud of dense interstellar gas, heating it and causing it to glow. Here, the blue matter is oxygen, from whose atoms 2 electrons have been stripped away. Red filaments are sulfur atoms, missing 1 electron, and green material is hydrogen. The Hubble Nebula, 7,100 light-years from Earth in Cassiopeia, is the front of an intense wind of particles from a massive star. There is debate whether it is a supernova remnant, a planetary nebula, or something else entirely. The center of the bubble is calm, unlike its surface, which is rippled from collisions with various clouds of cold gas. To the right of the central star lies a ridge of denser gas illuminated by the star. Intense ultraviolet radiation and the wind are photoevaporating this region faster than the others. Between the star and the ridge are never-before-seen loops and arcs, which may be a collision of the stellar wind with a wind from the photoevaporating ridge. Similar in ways to supernova remnants are planetary nebulae. When average-sized stars grow old, they deplete their hydrogen and helium fuel and become red giants. A stellar wind begins to blow huge amounts of their surface material into space. These gigantic clouds collide with other interstellar gas and begin to glow from the star's radiation. The name is a misnomer from the days when telescopes had only enough power to show these nebulae as disks resembling planets. A few thousand light-years away in the constellation Centaurus, a pair of stars created a planetary nebula resembling an hourglass, nestled within an hourglass. Together, the small bright nebula and the larger one are called the Southern Crab Nebula. At the center are 2 stars. A bloated red giant is throwing matter at a burned-out white dwarf. When enough matter accumulates near the white dwarf, a nuclear explosion occurs, creating a new nebula around the 2 stars. NGC 2440, about 4,000 light-years from Earth toward the constellation Puppis, is a planetary nebula created by a star becoming one of the hottest white dwarfs known. The nebula's unusually complex and chaotic structure suggests that the star has periodically ejected bursts of material in opposite directions. The nebula is rich in clouds of dust, some forming long dark streaks fluorescing in the star's ultraviolet radiation. From this perspective, the Ring Nebula in the constellation Lyra looks nearly circular. Could we rotate this image 90 degrees, we would see that the nebula is actually shaped like an hourglass. The hourglass shape is common among planetary nebulae, forming when thick disks of gas and dust around the waist of the star keeps gas from expanding on that plane, forcing it to flow out from the poles. The Ring Nebula is about 2,000 light-years from Earth. The speck at its center was once a star bigger than the Sun. Suggesting a parka-hooded Eskimo, NGC 2392 is actually a disk of material embellished with a ring of comet-shaped objects streaming from a dying star. The bright central bubble is the star's intense wind blowing into space. This nebula was born about 10,000 years ago and, like the Ring Nebula, is really 2 lobes of matter streaming from the star's poles. From this angle, one lobe lies in front of the other, obscuring part of it. This image of M29, the Butterfly Nebula, offers a better view of an hourglass-shaped nebula. 2,100 light-years away, the Butterfly surrounds 2 stars orbiting each other so closely that one has engulfed the other. They are flinging gas into a thin, dense disk around themselves. When the wind from one of the stars rams into the disk, it acts like a nozzle, deflecting the wind and forming the opposing pair of jets. The Ant Nebula MZ3 bears some resemblance to the butterfly, but it looks even more like the head, thorax, and legs of an ant. The gas and dust that compose the Ant Nebula are streaming from its central star at nearly 10 times the rate of the Butterfly Nebula. This picture, composed of 3 separate Hubble images, has revealed some unexpected details of an old mystery. The Hourglass Nebula, about 8,000 light-years away, has a bright elliptical ring in its center, with a symmetry axis dramatically different from that of the larger hourglass structure. The star believed to be ejecting and illuminating the nebula is also off-center. A pair of intersecting elliptical rings appears in the central region, looking like the rims of a smaller hourglass. Planetary nebula NGC 2346 surrounds a binary system 3,900 light-years from Earth. Astronomers believed the 2 stars orbiting one another were originally farther apart, until one grew into a red giant and swallowed the other. The second star spiraled towards the core of the red giant, spewing a ring of gas around the binary. Later, when the core of the red giant was exposed, it ejected a fast stellar wind at right angles to the ring, inflating 2 huge bubbles of gas. The 1,000-year-old Cat's Eye Nebula is one of the most symmetrical and complex planetary nebulae known. Its intricate concentric gas shells, gas jets, and shock-induced knots of gas create a visual record of the evolution of a dying star. Its complexity may be generated by the dynamics of a binary system at its center, though in this image, the 2 stars would be so close as to appear as a single point of light. NGC 6751 in the constellation Aquila suggests a glowing eye at the center of the cloud it ejected thousands of years ago. This picture is a combination of 3 images captured by Hubble's Wide-Field Planetary Camera 2. Different colored filters isolate gases of different temperatures. The hottest gas forms the round blue ring. The orange and red streamers and the outer ring are cooler gas. The Calabash Nebula is sometimes called the Rotten Egg Nebula because it contains a great deal of sulfur, which, if there were smells in space, would smell like rotten eggs. About 5,000 light-years from Earth in the constellation Puppis, the nebula's yellow twin jets are its densest parts. They represent most of the star's original mass, blowing into space at up to 1,000,000 miles per hour. Where these jets ram into various other material, they form shock fronts that ionize hydrogen and nitrogen atoms. The complex blue double bubble here is the light from these shocks. The Spirograph Nebula, IC 418, lies about 2,000 light-years from Earth in the direction of the constellation Lepus. At the center of the nebula is the hot core of a former red giant, pouring ultraviolet radiation into the surrounding gas, causing it to fluoresce. Here, blue represents ionized oxygen, hydrogen is green, and ionized nitrogen is red. The Southern Ring Nebula is nearly half a light-year in diameter and about 2,000 light-years from Earth. Hubble shows 2 stars near the center of the nebula, a bright white one and a fainter companion. In this image, blue and red represent the hottest and coolest gases, respectively. The filaments, including the long one around the nebula, are carbon-rich dust particles that condensed out of the other gases. Eons from now, these particles may again become parts of new stars or planets. Deep within the Helix Nebula, 450 light-years away in the constellation Aquarius, thousands of gigantic tadpole-shaped objects surround a dying star. Called cometary knots since they resemble the heads and tails of comets. They are probably the final outbursts of a dying star. The head of each is at least twice the diameter of our solar system. Astronomers had hypothesized such objects but had never seen them in such abundance until this Hubble picture. Over time, these bodies may dissipate and vanish into the cold emptiness of interstellar space. But if dust particles within them